All right. All right, everyone. Welcome to July's DataWorks Maryland meetup. Very excited about this one. We have a special speaker. She's previously spoken at a couple conferences. Hannah, she's going to be discussing the Datawave project, which actually originated at NSA, and she's basically an expert on. So it's a very interesting architecture. And if you have any interest in big data or data storage and indexing, I think this is something you'll be interested in. Before we get started, I always like to thank our sponsors and just give a little bit of information about some upcoming things. So Varen Technologies has been sponsoring us for probably about 6 or 7 years. They're a defense contractor in the Maryland area doing a lot of interesting work. If you'd like to learn more about them, please reach out to me or directly to them. ClearEdge is another defense contracting company. There's always a theme here. And they also do a lot of data science and data engineering work. They might do a little more than the Maryland area. So if you're interested in learning more about them, you can reach out to me or contact them. Areas Ventures is my company. If you want to learn more about that pretty clearly, just reach out to me. So upcoming, so next month, I was actually just telling Hannah this, we're planning on being back in person in Baltimore, talking about quantum computing. It's a pretty interesting topic. Basically, the speaker found a use case and wanted to show like how you actually take the problem and can solve it with quantum computing. We previously had done a quantum computing discussion that focused a little more just like on the architecture and didn't really get into the use cases and like how you would actually do work in a quantum computing. So that's pretty interesting. And then in September, we're working on an event that would be focused on data science education, kind of like how they're teaching data scientists in the government. So we're still working on that one a little bit, but that one's kind of in the plans. And then we are still trying to do a conference and really need help. Like if people want to enroll, the sign up's a little different. It's not on Meetup, it's on Eventbrite. So if you're interested, please sign up there. And if you have a recommendation for speakers or anything, please shoot me an email. Really would appreciate it. So Hannah received her BS in mathematics from the University of Maryland, and she was a software engineering intern at Northrop. And really, I'm going to skip this a little bit, but she kind of really is an expert on big data and data storage and has done a lot of work in that area. She recently joined Tiber Technologies, and I've seen some of her talks before, and they're really interesting. And I believe she's going to do a little bit of an interactive or a demo as she's doing the talk. So if you have any questions, the way that I would like to do it is just type your questions into the Zoom chat. Or if you're on YouTube, I'm watching that also, you can type your questions into YouTube. I'm going to gather the questions and then I'm going to ask them to her after she does the presentation portion. But feel free to send the questions privately or publicly and I'll get them captured. So with that, I'm going to give up sharing, hand it to Hannah, and then you can get started.
All right, thank you so much. So first of all, can everybody hear me okay? Can I get a thumbs up? Good, thank you very much. So my name is Hannah Pejon, and I have been working on Datawave, now that I think about it, for going on a decade. And before I get started, I did want to shout out to all of the great minds who poured in a great amount of time and effort into Datawave, even before I got there, making it possible. And in particular, I did want to call out my colleague, Drew Ferris, who co-presented with me at Accumulo Summit last year. Some of those slides are reused here with his permission and my thanks. Let's see. So this presentation will overlap a good bit with that Accumulo Summit presentation. For those of you who did not have the opportunity to see it, you'll still have the benefit of the introduction to Datawave. But for those of you who have seen it, I will be going into a little bit more detail in each section, sort of peeling back that next layer of the Datawave onion. Starting off with the prerequisites for Datawave, the underlying technology stack that it's really recommended that you have a good foundation in before going on your Datawave adventure, as it can be a bit tricky for anybody who has dealt with big data and distributed platforms before. I'll give a very high-level overview of the architecture, go into some of the key concepts, some of the subtleties of Datawave and gotchas to give you an idea of whether or not Datawave may be good for some of the problems that you are trying to solve. I'll give a high-level ingest overview, query, and throughout the presentation, I'll give some examples of some applications and frequently asked questions. Since the presentation in 2018, a number of user groups and individual people who have wanted to start using Datawave have asked a bunch of questions. I guess calling it frequently asked is a bit generous, more like common problems or stumbling blocks and gotchas and things like that. So, right, moving on. So the prerequisites for running Datawave are Hadoop, Accumulo, Zookeeper, and Wildfly at least. It's also highly recommended that you understand Java very well, because I think the product is somewhere in 98, 99% Java. So I think maybe some members of our audience will be familiar with most of these, but I'll give a high-level overview of each one. Hadoop is a platform for distributed computing that helps you orchestrate, thousands of nodes together, and it's comprised of a few main components. HDFS is Hadoop's distributed file system, which by default will store data in triplicate to address some issues of fault tolerance. That way, it's very unlikely for you to lose any data. Yarn is yet another resource negotiator, essentially a scheduler where you can launch applications and containers across your cluster, and MapReduce is the processing framework consisting of a map phase separated by shuffle and sort, and then a reduce phase to break down your data set across numerous nodes. Accumulo is a large-scale distributed key value store with built-in cell-level security. So that way every individual cell is protected at its own security marking. And Zookeeper is a coordination synchronization service that is necessary for Accumulo handling certain key configurations, but Datawave does use Zookeeper in other ways as well, built into Ingest in a few other ways. And Wildfly is our application server handling the Datawave web query services. Right, so what is Datawave? It is a giant ingest and query framework that is built on top of Apache Accumulo, taking advantage of all of that underlying fault tolerance and cell-level security. Some of the main things that Datawave provides is a very highly tunable and customizable ingest workflow. There are dozens of dials and knobs to turn. So if you're continuously ingesting data, you can get that flow just perfect into Accumulo without taking it down. Another key thing it provides is a good generic table schema that works with just about any data type. I remember when I was working on a bunch of internal research and development projects before this, all centered around Accumulo, every individual data set had its own unique flair to it, and a great deal of time and effort was spent in trying to figure out what sort of table schema in Accumulo would work. How do we prevent hotspots? And so Datawave provides that out of the box. You don't have to spend those weeks or months contemplating how you want to be able to store your data without having hotspots and things like that. I'm not saying it's entirely immune to those issues, but it is an excellent starting point to save you some time. We also provide a query API, because what good would it be if we can shove all of this data into Accumulo and not let you get it back out again? The query portion of Datawave also parses and plans the query, so it takes into account certain things about your fields and values, certain attributes, and tries to optimize the query. So it's not just this brute force, here's my query done. It does look over those attributes and try to make your query execute as efficiently as possible. And again, I had already stated that Datawave will support numerous data types because that table structure is wonderfully generic. So you can have everything all co-located in the same set of tables and queryable. All right, so Datawave just acts as this ingest and query framework. So bookending Accumulo. And that infinite tunability is really beneficial. I do remember so many times it was difficult on those IRADs to get the right blend, achieve that right balance of shoving data into Accumulo while querying it back out again without Accumulo falling over. So Datawave allows you to tune all of these things so that you can get data into and out of Accumulo as quickly as possible, supporting many different data types. Taking a deeper look into Datawave's architecture, step-by-step guide, as it were. Typically, you'll have some sort of data routing service like Apache Niagara files dropping data into HDFS. You could also just shove data into HDFS yourself or have something that has numerous data feeds, but ultimately it does need to wind up in HDFS. Certain directories in HDFS are monitored by the Datawave flag maker, which constructs a flag file that consists of the list of files to be processed and the command to kick off that MapReduce jobs with any custom configurations you may have per data feed. The ingest server, which is not shown, kicks off the Datawave ingest job, which is a MapReduce job that goes over those files that were listed in that flag file. And Datawave has two main ingest routes. It has a live queue, which sends data streamed directly into Accumulo, and a bulk queue, which produces R files. It drops them back into HDFS, which is monitored by the Datawave bulk loader. And then those R files are bulk loaded into Accumulo through its regular bulk import process. Over on the query side, we have HA proxy as our soft load balancer between multiple web servers, which are running Wildfly. Those queries are submitted against Datawave's REST API, which does that parsing, planning, and configures a query logic that then configures some iterators to run over that data and the Datawave tables in Accumulo and stream results back to the users a page at a time. All right, some of the key concepts of Datawave. What is a record in terms of Datawave? It really is just a collection of fields and data. The actual class that we use in Datawave is the raw record container, but as you're reading through documentation, code, and comments and things like that, you will see it referred to synonymously with an event or a document. Fields in Datawave can have multiple values, multiple instances of the same fields, and you can decide whether you want it indexed, reverse indexed, or maybe there's some field in your data set that's junk that you don't want to bother bloating out your database that you can exclude. And there are some special cases of fields, which I'll touch on in a little bit, but here's where I start to say, know your data, know how you want to be able to access it, what your end users want to be able to see and query on, and configure it appropriately. And over on the bottom right-hand corner, I have an example of a data type config file. You will have one of these for each main data type that you want to ingest into Datawave. And that's where you customize that individual feed. And I've got the examples of how you define certain fields to be indexed or reverse indexed below. Normalizers are a key component of Datawave. They provide a standardized view for a given field. And I had one group, let's see, I'm trying to remember their exact use case. Right, they were trying to ingest traffic violations and speed camera data. And they were trying to search for speed cameras that were triggered when a car was going between 10 and 20 miles per hour. And they had actually gotten back a result that was 100 miles per hour. And they reached out, they were very confused, saying, how on earth did I get something that's 100 miles per hour when I asked for something between 10 and 20? And it turns out it was because they had configured their miles per hour field to be essentially a string, or LC no diacritics, which is lowercase and removes any diacritic, any accents or umlauts or things like that. And they had not configured it as a number type. Accumulo stores data lexicographically, and in lexicographical order, 100 does appear between 10 and 20, and that's why they were getting it back. So upon configuring the appropriate normalizer, they were able to get the data back as they expected it. Alrighty. There are many different tables in Datawave, many more than are displayed on the screen at the moment, but to me, the the beef of it, the bread and butter tables, are the shard table, the global index, metadata table, and the edge table. Your global index, as you might be able to guess, is a system-wide index that makes references to shards in the shard table. Your shard table is partitioned by date-based shards, and I'll touch on that date-based connotation in just a minute because that can be another gotcha for some people. And every individual shard has its own field index, which is a shard-specific index referring to specific documents, the full record storage, the data storage if you've got some blob of content, and the term index. So if you have a paragraph of text in one of your fields and you want to be able to search on individual terms within there, those individual tokens will be stored in that term index. And then we have the edge table, which helps track relationships between fields for a given record. So I mentioned that shards are date-based. And the reason why that is important is because your queries have to have a begin and an end date, unless you allow for a full table scan. For small data sets, that can be fine, but for larger and larger data sets, it's better to be able to narrow down the ranges that you're scanning in Accumulo. And so some data may have intrinsic dates, such as, well, that speed camera data set. You probably want to be tracking the time that the violation occurred. Also, for any data set where you're trying to track trends, I'd had another group who was trying to monitor purchase trends, sort of like a recommender engine. You know, these two products were purchased together, but they wanted to see how products were doing over time and when things sort of fell out of fashion. So you don't necessarily want all of your data to be the load date, which is the date that you are actively ingesting that data into Datawave. You may want to define a particular field that defines the shard that the data goes into. And the way that you do that, again, is in your trusty data type config.xml file, setting the category date field name. All right, so what are the structures of these tables? I'm not going to go through every individual piece of it because that would get monotonous and boring very quickly, but mainly for your reference, if you decide to download the Datawave Quickstart, here's a guide for what you're looking at in each table, and I will be calling out certain key attributes of the tables, but mainly these are just here for your reference. One thing that I did want to call out about the shard table is those different partitions of it, the separate field index, record portion, term index, and the document pieces. For the term index, one interesting thing about Datawave is that we store the term offsets. So if you are trying to look for documents that contain certain phrases, like maybe you're looking for banana pudding, and you want to make sure that those terms appear closely together, those offsets are tracked. And so you can see if certain terms are adjacent in those queries, as opposed to having one giant document where pudding appears in the first paragraph and banana appears in the last one. The shard index and the shard reverse index have the same structure. The main difference is that the reverse index flips the normalized field value, so it's backward to support leading wildcard queries. And one thing that I wanted to call out about these tables is that in the value portion, we store a UID list of the documents. So for each document that contains that particular term or value, you will have a list up until a certain point. If you have a really high cardinality field that is pervasive across many different documents, those get aggregated into that UID list size. So it will give you a count per shard per data type that field occurred. And that is very important for query execution. And I'll touch on that in a bit more detail later. So here we have an example of a query. Maybe you have some data set of people's favorite things and you want to know whose favorite food is banana and whose favorite car make ends in I, demonstrating how the shard index and shard reverse index work together. So banana is forward indexed. So the query will first look at the shard index and it'll determine that you have banana in document 1 and shard 0, document 2 for shard 1. For the reverse index, everything you see is inverted. So we've got Lamborghini, Ferrari, and Bugatti, which occurs in shards, shard 0 for document 1, 1 for document 2, 2 for 3, 4, and 5. Datawave query will perform the intersection of that, so it knows it only needs to search shard 1 for document 1 and shard 0 for document 1 and shard 1 for document 2. And there are ways of adding efficiency with this because there are certain queries that can be evaluated against the index as opposed to having to go down into the record portion of the shard. And then it'll pull back those results, and you can see that you've got some guy named John Smith who likes bananas and Lamborghinis, and some chick named Jane Doe who likes bananas and Ferraris. All right, the edge table is a great way of tracking relationships between fields over time. I mentioned that data set of purchase trends, buying a bunch of things together on Amazon, and it tries to recommend people who bought this also bought this. The edge table will keep track of 2 entities. Most of the time, edges are bidirectional. So later in the table, there will also be entity B mapped to entity A. It tells you the edge type and the specific relationship of each entity to each other. And the protocol buffer and the value will keep account per hour per day. So if you are trying to monitor trends in pairs of fields over time, the edge table is a great place to start. So here's an example graph. We've got Kevin Bacon starring in the TV show Tremors, portraying Valentine McKee, co-starring with Emily Tremaine, who is portraying Emily McKee, et cetera, et cetera. And so here you can see the different relationships of the nodes between each other. And this is roughly how it looks like in the edge table. So you have entity 1 is Kevin Bacon, has been mapped to Emily Tremaine because they are co-stars together in the movie Tremors. And the relationship, these are real people, so we're defining that it's a person-to-person mapping. So the mapping from Kevin Bacon to Valentine McKee, he is starring as that person, so it's a TV character edge type. And so you have a person-to-character edge, if that makes sense. And then there's additional cruft that I have omitted for the sake of simplicity here, but there's more information in the protocol buffers that I haven't shown. And out of the box, Datawave does provide you with some examples of this. So the quickstart will ingest a TV maze data set, and we do have a sample edge definition list that is defined. So essentially you say what edge type you have, the relationship of the edge, and what fields that you want to have edges generated against, if that makes sense. The Datawave metadata table is extremely important. It tracks what fields have been ingested over time and certain key attributes that are also used by Datawave query. So the E column in the metadata table signifies that this field is present in the record portion of the shard. I indicates that it has been indexed. You can probably guess RI means that it's reverse indexed. T defines those normalizers that I mentioned earlier, and you can have multiple normalizers for a given field, but there are there's some outcome from that you may or may not want. So again, it's very important that you know your data. It tracks the frequency of these fields over time. It gives you a count per day. So it's a good way of tracking what you're ingesting. If you want to just look at it, this is what we call the data dictionary portion of the Datawave metadata table. Let's see, the metadata table also stores a query model, which I'll go into some depth about later, and it also stores some edge metadata, such as what fields have gone into producing a particular edge. So it's very useful for diagnosing certain problems with query and seeing how your database is actually being used. So moving on to the query portion, Datawave query will support both Jexel and Lucene syntax and a bunch of functions. I'll give some examples of a little bit later. I mentioned how that execution is shaped by the data characteristics, whether it's indexed, whether it's a high cardinality field or a low cardinality field, and we'll configure iterators to perform those low-level functions on the T server. That's the great thing about distributed computing. You're always trying to push that heavy lifting down as close to the data as possible. And Datawave provides a REST API, the most common sequence of API calls. There are more endpoints than I have listed here, but just the typical workflow is that you know a priori what query logic you want to use. You call create on your query along with a bunch of parameters in your query string. And this portion of Datawave will parse and validate that query, make sure your syntax is correct and doesn't have any errors. It'll look at the fields that are actually part of your query, check the Datawave metadata table. It'll see what attributes those fields have to determine how your query can be executed and evaluated. If that is successful in the create phase, you'll get back a query ID and you can call next on that query ID, getting back pages of results. And then when you're done getting results or you get a 204, the close endpoint will be called, freeing up some Accumulo connections and opening up space in your web service pool to allow more queries through. All right, one key subtlety, I guess you could call it a subtlety, is grouping context. I had some people reach out over time because they were deeply concerned that certain intrinsic relationships between fields might be lost upon ingest into Datawave. And so in this particular example, you can see the grouping contexts that are appended to the field name. So you had field name dot context, and you see item dot zero is related to cost dot zero. It would be very silly to have a banana cost $500. So in this particular example, though, of the query, this record one would come back, even though you can clearly see in this particular purchase, bananas only cost 69 cents each. But there is still a cost field present for the value of $500. So this record would come back. If you want query to acknowledge those intrinsic relationships, there's a query function called matches and group, where you want to ensure that the item field you are checking is related to the cost field. And this can get a lot more complicated. Different hierarchies can be preserved in this way as well. If you've got, think nested XML attributes, where you've got a parent and multiple children, it will maintain those relationships by having the first instance of a parent dot the first child dot the second child, etc., keeping track of those relationships across your database. Matches and group is just one example of many different query functions that you can use in Datawave to further filter out your data and be very specific with the question that you are asking. All of these are documented at length in the documentation link that I think Jason was kind enough to put out in the meetup notification for this. But it's also included in the Datawave README if you go to look at that code base in GitHub. The README contains a link to all of the documentation where you can see all these different wonderful functions that you can perform. It's worth mentioning that you can integrate Datawave with GeoWave if you have some sort of geographical keys in your data, and maybe you're trying to track trends over time in certain places, like maybe COVID outbreaks or something like that, and trying to determine per region how many cases there are. There are multiple query logics that you can use per Datawave. I've only listed a few of the most common ones here, and query logics essentially dictate what table your query is going to be executed against, and certain methods about how that query is going to be executed, as well as the type of results you want to have returned to you. The most common is the event query, which is a simple record retrieval. Given a query, give me back the entire record for every record that matches the query. You can fine tune it with those functions and some additional parameters, but I'll leave it at the simplest example for now. Lookup UUID is a hyper-optimized version of the event query, but it assumes that every individual record in your database has a unique identifier and a particular field representing that. The edge query provides you with a way of searching through edges and then checking the events that generated those edges. So if you were looking for those 6 degrees of Kevin Bacon, performing an edge query on Kevin Bacon, it would gather every other entity that he's associated with and then construct a follow-on query to go against the shard table and pull back the record that produced those. Discovery query is useful if you don't necessarily want the entire record to come back. Maybe you just want to know the number of occurrences of a particular scenario, something rolled up into account, an existence check, something like that. And then a metrics query. I haven't yet mentioned the query tables, but every single query that is executed against Datawave will be recorded in a set of query metrics tables. Provides a great way for troubleshooting or seeing how users are using that system and seeing, given this query, what plan has been constructed and other really useful details. And I'll try to remember to go through that when I go through the quick start. All right, query models provide you with a way of searching many similar fields, but only with a single term. So there are many fields that can be very similar in purpose, but different in name. If you don't necessarily have control over your field names a priori, and you don't want to have to type out these exorbitant strings every single time, you can specify a forward mapping in a query model, and Datawave will be smart enough to do what's called model expansion on that query. So instead of having to remember all the different flavors of IDs that you have in your database at query time, you can just do IDs equals whatever ID that you're looking for, and Datawave will expand that out into account ID or account number or whatever you've already mapped, so that you don't have to type this out every single time. All right. So hopefully some of the examples that I gave earlier are helpful to give you an idea of certain applications of Datawave, maybe where it would be useful, where it wouldn't. But essentially anything that you can parse out into field value pairs, you can store into Datawave and query it. For fun, I decided to look for open data sets that were related to healthcare, load them into the edge table, and I found a UCI health study data set on heart conditions, and also ingested one of the World Health Organization COVID data sets. And it was just fascinating to scan the edge table after the fact and see these symptoms mapped to causes. And so you can see myocarditis as a symptom of COVID-19 next to all sorts of other things. So for health professionals trying to do these correlations, it could be useful. Again, correlation is not causation. You can have some pretty crazy correlations that don't actually need anything, but it is very cool to have all of these associations centrally located, no matter what the ingest data type was, all co-located and searchable in one table. I mentioned purchase trends, tracking things over time for recommendation engines. Network security, right. There was an IRAD group who contacted me some time ago. They decided for their data set, they were going to do some packet captures on their company network or their home computer and ingest that into Datawave and try to see what interesting things they can divine from that. And they took the edge table and extracted it into some follow-on application that they had written using a query logic. And they did a fast Fourier transform over this and saw peaks every 10 minutes. It was fascinating. They found somebody who was trying to port scan their network every 10 minutes. So that was exciting. Those are just few of many possible applications to Datawave. It really is ridiculously flexible. So itemizing the applications is a bit difficult to come up with them all at once. So that's all I have in terms of the presentation. I'm going to have some water and then I'll bring up the Datawave quick start and poke around some tables.
Oh, was I muted?
Yes. Sorry.
Oh, I was asking a question. Let me start again. So
I'm
I
so
was saying
sorry. I
if
didn't hear you at all.
yeah, it was me. So if anyone has a question, feel free to type it. But I was saying I had some questions for you. Knowing the project a little bit, I've always wondered like how the work is and what the amount of work is. And you kind of talked about it, but you said that you had loaded some of the COVID data to play around with.
Yes.
So like in that particular case, how much work was that for you to get to the point where you were actually getting value out of the loading? Like, was it just configuration things? Was it like a couple hours, things like that?
Right. Well, first, I spent a lot of time looking for a data set that could correlate some interesting things. But in terms of start to finish, it probably took me 4 hours to get it in. There was some non-trivial things about the data set. I think one of them was CSV, the other one was JSON, which we already have examples for out of the box, but um, I had to go through their entire list of fields, think about what kinds of correlations am I going to want, what edges am I going to want created, and their field names were not the same, so I had to do some internal mapping between those fields to get it to appear that way in the edge table. So again, there's a lot of time surveying the data set mostly. The actual configuration piece wasn't that bad. I wish I had tracked how long that took, but
So when you're doing what the work that you're saying though, is that writing Java code or is that just some of the XML configurations that you showed?
it was mainly XML. I did
Okay.
not need to create any custom readers or anything like that since we already provided the JSON and the CSV. It was
Okay.
mainly those XML configurations, some of those examples that I provided.
So the groups that are contacting you, do you find that it's the same for them or do you find that they're doing a lot of customization?
A number of groups have come up with their own custom record readers,
Mm.
but largely building on what's already there. Let's see, some of the custom record readers that they wrote extend the classes that we've already provided, and they override certain methods to, I don't know, add their own special sauce. I'm trying to think of that speed camera data set that I helped some people with. One of the gotchas was that they painstakingly went through listing out the headers of their CSV file, which dictates what those field names are called. And they didn't really need to do that because the header was present already in their data. And that's something that I didn't mention. If you already have a header in your CSV, Datawave will assume that that is what you want your field names called. You didn't have to go through and type out everything. And you still need to say, I want those fields indexed or reverse indexed and things like that. But yeah, it does seem to be the same for a lot of these people.
So this question might be a delicate question. I don't think it is, but there's so many products and the data engineering ecosystem is huge. Are there competitors to this? I mean, it's a pretty, thorough architecture handling everything from ingest to query. Are there other solutions like this?
So let's see. Questions that I have been asked about, I guess you could say competing technologies. The two I think that I've been asked about the most are Elasticsearch
Mm.
and D4M, I think was the other one. So for Elasticsearch, the idea of ingesting a ton of data, distributing it, and querying it out pretty quickly. Datawave queries act mostly like the filter function in Elasticsearch. But one key difference for me was that I think Elasticsearch makes no guarantee that your data is correct. There could be some catastrophic collisions or data might get dropped. And for Datawave, that's really a non-starter. We really do try to ensure that if there's so many checkpoints and error handling cases along the way that we try really hard to ensure that barring some crazy bug, no data is lost.
That makes sense. So is the architecture set up that, and maybe people have done this, that you can switch portions out, like the NiFi? Could that be like a Kafka, or
Oh yeah.
could you actually replace Accumulo with HBase if you really wanted to, or is it too coupled on certain areas?
So let's see, the column visibility portion is extremely deeply ingrained, and there are a lot of assumptions throughout the query code for how to handle that. I did work with HBase before working with Accumulo, but this was, this was quite a long time ago, and I haven't checked back in with HBase some time ago, but the APIs were very interchangeable. It's just that the column visibility is a key portion for Datawave, and HBase is optimized for reads, I think, and Accumulo for writes. So the idea just to get it in as quickly as possible so that it's available for query.
So I was curious because it's kind of unique. I mean, you kind of alluded to this. This project started as a government thing and then kind of went open source. Has that been, I'm more curious, has that been interesting, like working on a project that straddles both? Has it been challenging? Is it?
It has, yes, in its own way. It's nice that I'll get to telework from time to time now, but we're constantly looking at pull requests, making sure, things like that, trying to be very careful. And what else to say about that?
Have you, I mean, kind of go into that. Have you seen there being input from the community outside the government? Like, are people doing interesting pull requests and updates that you guys are integrating?
I haven't seen any of that yet, but then again, I haven't checked to see who's cloned the repository since. It was pretty cool to see, some of these individual users and IRAD groups who had reached out, with their own companies, just doing some research, trying to make Datawave work. I do hope that at some point, some of that will reach production and that we will see some bug fixes from some of these other groups, but it's very much in its infancy.
That makes sense. Well, you can do you can show what you wanted to show, and if anyone has any questions while she's doing that, I can capture them and ask after the demo portion. Does that sound good, Hannah?
Yeah, sounds great. Alrighty, so can you see my terminal? Yes. Good.
Yes.
Okay, great, thanks. So I have already built Datawave, and it took quite a while downloading all of the Maven dependencies, so I spared you that 20 minutes or so. There are extensive instructions for how to run the quickstart. You essentially source the quickstart env.sh in your bash rc, source that, and then it begins to install and download all of the dependencies. And so now that I have done that, there are a number of shortcuts available to me now. So I'll just do the all install. Since I've downloaded everything, I'm now going to deploy Datawave. And just a few notes about this quick start. A few people who did try to deploy Datawave in a distributed architecture simply ran the quick start on each node. And so all that does is it spins up a singular standalone instance of Hadoop and Accumulo on that node. They're not going to talk to each other, and you're not going to have a larger Accumulo database. So you'll want to follow something like the Datawave Muchos repository, or go through and look at particular node roles and things like that before trying to distribute Datawave. So what's happening now is that we've started up Hadoop and Accumulo. We're making and configuring some tables, loading the job cache for ingest. For those of you who are familiar with MapReduce distributed cache, this job cache is like a central place where we put all of our jars for ingest jobs to use. And for whatever reason, it takes a while to put all of this stuff in HDFS at first.
What's the largest Datawave setup you've seen on the outside? Is anyone doing?
Let's see.
Like data wise and both like node wise?
For the groups who had contacted me with questions, I think one group had 100 nodes. Just testing it out, and that was the group who launched the quick start on every individual of those 100 nodes, hoping that it would gel together on its own. And so we had to sit down and explain particular node roles and how you want a central node kicking off your ingest jobs, keep your name nodes separate, keep your Accumulo master separate, et cetera, et cetera.
License, the speed thing was pretty interesting. Was that like a local government, like a county or something?
No, it wasn't. It was, let's see, what company was that?
That was a company. Oh, they were
Yeah,
trying to do
they were
something.
just,
Oh, okay.
they assigned these guys this task. They got a hold of this data set and said, hey, can you make this work, be able to ingest and query it? And they found Datawave, reached out through LinkedIn.
Wow.
Right, so some of this will look familiar to those of you who have run MapReduce jobs in the past. Those are all of the counters. We're ingesting those sample data sets, the TV maze data, which I think is that JSON set, some CSV, and also some Wikipedia data is being ingested as we speak. Yeah, so one thing that I did not touch on, but maybe alluded to a little bit, is that you can customize your failure scenarios for a given record or job. If there is, say, a critical field for you that must be present for you to consider your data good, you can have these event fatal errors to say, this record is no good, don't bloat my database, just dump it. Or if something is missing, malformed, you can specify whether you want it to fail the entire job. This whole data feed is junk, fail the job, I want to know, to be able to go do some debugging, or just drop individual records that might be incomplete. Records that fail get written to the error shard table, which is like, I don't know, I'm thinking of Link to the Past now, the light world and the dark world. The error shard table is like the dark world where all the bad records go. And right, so we finished ingesting some sample data. Now we're free to start the web app server. So it'll deploy and start up Wildfly. And then when all of this is done, I'll take you through some of those key tables that I mentioned, run some sample queries, and then take your questions, I guess. Alrighty, so I'm going to run the Datawave web test, which is a pre-canned set of queries. And it's a good canary in the coal mine test for whether a particular Datawave deployment broke anything, because we configure expected results, expected return codes, and things like that. So you'll see them scroll by pretty quickly when I do this. So here we see a bunch of passing tests, status code 200, some 204s. So there are some queries that we expect not to find anything for, things like that. And I guess it would be good for me to show you what some of those queries look like. I include very few examples in the presentation, but it might be beneficial to take a look at some of those. And all of these environment variables are set for you once you source that environment.sh piece. Back out one. Forgive me while I remember where these live. So run.sh is what actually runs those curl commands that you set up from these files that I'm about to show you. I guess I'll show you this Jexel syntax. Why not? Right, so this is sort of the minimum number of query parameters that you'll need to define. So the query string, any field is equal to anarchy. Touch on any fields later if you're curious, but essentially that means I don't really care what particular field it is in the database. Just give me anything that is equal to anarchy, and we'll talk about query execution for that in just a second. Giving your query a name is just helpful to you as a user if you're going back through metrics and you have a particular, maybe a recurring query, things like that you want to track over time. Those mandatory begin and end dates. Page size dictates how many results you want back per page. You can make this bigger or smaller depending on what really you're interested in. The auths portion, auths correlate to those column visibilities in Accumulo, so you absolutely must have the appropriate auths for that visibility marking or you'll get nothing back. The column visibility below that is for the query metrics, because maybe there's some sensitivity to what you're querying on. I don't know, maybe think HIPAA violations and things like that. If a doctor is searching for a symptom in a patient, you don't necessarily want the world to see that. And then you specify your syntax. And so all of this gets executed as just a simple curl statement against the Datawave query endpoint. And let's see, there are a number of other examples. I've seen people cannibalize these tests and just put their custom queries in there for testing purposes. The quickstart is a great way of dipping your toe into Datawave, getting familiar with the architecture, the layout, and all of that. But long term, if you're thinking of actually doing a real installation, you're going to want to move to Datawave Muchos or do a more distributed installation. And let's see, it provides you with a nice Accumulo shell shortcut. And here are some of those tables that I told you about. Let's see. Take a look at that shard table. Maybe some of the stuff I mentioned before will make sense if I scan that, showing you the different sections of each one. So the first section that we're in right now is the field index. You can tell that by BFI. So again, this is the per shard index, and we've got this field, embedded cast character name, the value, and the data set that it came from. And if we just keep on going, here's
Is there
the,
I was just wondering, is there an expectation that someone that's using this would have to create any of their own tables, or is it kind of like everything that you really wouldn't have to do that, would you?
You don't have to do that. When you start your first ingest job, if you add a create tables flag, it will automatically create those tables for you based on those configurations. Yeah.
Okay.
Great. So this is the term frequency portion of the shard table. So for, I guess, for the TV maze data set, there was a summary field that was probably describing the movie. So every individual word in that summary has been tokenized. So if you're looking for a particular genre or story about something, you can do some of those phrase queries and get back movies that match that. And here we are at the record portion. So your shard date and ID, the data set that it came from, your document ID, field name, and your field value, which in this case is not normalized in the record portion. And let's see, I think that's probably all I want to show you about that, though. I talked a good bit about query planning and how that can manipulate your query to try to optimize it in some way. So maybe showing you the metadata, the query metrics table. Beneficial. So going to the query metrics shard table. Again, it's got the same structure, field index, et cetera, et cetera. And so let's see. Scroll until we find something of interest to show you. So here's an interesting thing. Here's the original query. Just give me the page ID of 10. And when you see it in the actual query plan, you'll see that that 10 has been normalized. So the normalizers that I mentioned before are performed both at ingest to get it into the database, but also on the field that the user is supplying in their query to make sure that you're comparing to apples, or I guess bananas to bananas, as was the case with that example. And the one that I wanted to show you was the any field query. So, right, let's see. Any field is equal to anarchy. So what the Datawave query will do is it'll go against the index and determine what fields anarchy appears under. And then when it's constructing your plan, it will substitute any fields that it found those values for. It's just one very simple example of how query plans get modified from the original query. And I think those are all the main things I think I wanted to show you. So if anybody has any questions, I'm happy to answer.
So I had a question. I haven't seen. If anyone has any questions, please send me a message. But so where's the future of this? Like, what's the next
step?
Are there new? Yeah. What's the like new features, or is there new things that are going on?
Sure. So immediate milestones are integrating Accumulo 2.0. I think we're on 193 something at the moment. And we're trying to break down Datawave into more manageable chunks, trying to break it out into microservices, Kubernetes them. Let's see, we did a fair amount of that for the query side already, but now one group is trying to break the logics into individual microservices. And there's plenty that we could do ingest side in the same way to, rather than do these large monolithic deployments of Datawave, break it down into smaller, more manageable chunks.
Do you guys track performance and metrics on this, like on the architecture itself, just to have rough ideas?
Yes, so there are some system metrics built in. Let me see, do we have these with the quickstart? Let me see. It appears not, but throughout each stage of the ingest and query pipeline, there are metrics that we gather. All of those counters that you saw scrolling by for those ingest jobs, we record those to see how long is ingest taking on average. And for query, you can see here elapsed time. We are keeping track of how long queries are taking. And there's extensive monitoring of Accumulo to make sure that it's happy and correlating maybe some query slowness with some Accumulo hiccups and things like that.
Cool. There was a mention to has there been some involvement from Google? There was a comment on YouTube about a Bloss. A gentleman that you might know.
A Brian Loss.
Oh yeah. It says B Loss. Yeah. Is that
Yes, he is a colleague, a well-esteemed, very well thought of colleague.
Okay. Yeah, I was looking at the Git while you were talking, and I saw there was a number of pull requests and issues that have been reported. So it looks like it's a fairly active community. It looks like people are involved in using it. It's pretty cool. Well, I think that's it, and I don't see any other questions. I think that was pretty awesome. I think that's a really good walkthrough. Like if anyone wants to get started, I think this is a good place to start to get a good understanding, and especially the way that you demonstrated at the end. Do you have anything that you would like to end with? I mean, do you want to say anything about projects or things that you're looking for, or people should contact you if they have more questions? Or
Oh yeah, you can contact me through LinkedIn if you have any further questions or you have a use case that you want to see if Datawave might be a good fit for. My main takeaway for setting up these kinds of databases is you really have to know your data and how it's going to be used a priori, because sometimes going back and fixing things up after the fact is a royal pain. And let's see, thank you everybody for joining me. This was a lot of fun. I hope you got something out of it.
Yes.
That's it.
Yeah, thank you. And thanks for everyone that joined us. So we'll see you guys in August. The video will be up. There's a lot of resources. If you look, information about Datawave, Hannah's information's up. So if you have any questions, please reach out. And thank you, everyone. And I hope everyone has a good weekend. Thanks, Hannah. Great job. All right. See you guys.